Okay, in this video, I'm going to show how to run independent sample t-test. So let me make it bigger. Okay. So again, this folder is available on Blackboard, and it's a zipped folder. So you basically need to download the zipped folder and unzip it. And after unzip it, when you go into this folder, you will see this folder structure. And this icon here says lab-inferential stats. And this is an R project icon. So if you installed RStudio and R, and if it is working on your local machine, you may need to associate R project folders with RStudio. And if you do that, you will see this blue icon here. If it doesn't do it automatically for you, then when you open RStudio, you go to Open Project, and you can go direct with Open Project to this folder and select this icon and work it that way. So instead of double clicking on this one, that's how I'm going to do it. I'm going to go to RStudio, open RStudio, and from RStudio, I'm going to open this folder. Okay. So RStudio is opening now. And so basically what you need to do is go to top right. Since this was a previous folder that I was working, it automatically opens that one, but if it wasn't the case for you, basically need to click that corner here, top right, and say Open Project. And you need to figure out where the file path is. In Windows, it's usually you copy this, select the address bar, and then highlight all of them, and you can just copy it and go back to RStudio and paste that address here, and then put this icon and go there, and then you see that lab inferential stats. If you select that one and click open, you will see this one. So in this exercise, what we're going to do is we're going to run independent sample t-test, and it's the fourth one here. So I'm going to open that one, left click. Okay, so it opened, and for this file, the data is not in an SPSS file, it's actually an Excel document. And to bring a data from an Excel document, you use the function read Excel. So I'm going to load these packages first by clicking Run. And packages are loaded. These are just warnings. So these are not very important, so you can ignore those. And yeah, so line 12 is saying, I have a data file called for-happy.xlsx in data folder. The first thing is let's make sure that it's there. So at the right bottom panel, you will see a folder called data, and it's like for-happy.xlsx. Yes, that file is here. So we make sure that the data is there. So then we can click environment. So our environment is empty. So let's read in our data set. And to read the data set again, you need to bring your cursor either at the beginning or at the end of the line. And you click run. Okay, in this data set, I have 45 observations and 2 variables. Let's see. Let's open the data set. And the first column says tips and the second column says happy. So basically the first one is the tip amount and the second one is whether the participants received a check with happy face drawing or not drawing. All right, but how do I know that? Because I provided that storyline here. So, but before we start, independent sample t-test requires that your variable is categorical, your outcome is categorical. So this is line 14. Basically help you do that. And just enter this comment here. Make sure that it's categorical. And categorical variables in R are called factors. Okay, so and in this data set, I have 2 variables again. The first one is the tip amount, and that's like a dollar value, so that's a continuous variable. And happy face versus no happy face, so that's a categorical variable name. But you have to explicitly tell R that that's a categorical name or factor. So before I make happy as a categorical factor variable, I just want to see how it looks like. And to call a variable from a data set again, you have to enter the data set name and a $sign to call a variable from that data set, and you need to enter the variable that you are calling. So let's run line 15 now. Okay, it looks like, yeah, happy face. And yeah, line 16 basically makes that categorical variable. And I'm just gonna run that one. Okay, so did anything change? So let's rerun that one again and see. So we called my data $happy twice. In the first one, we didn't run we didn't make it factor or categorical variable, and this is what R printed. In the second one, we run that one after we make that variable a factor or categorical variable, and this is what R came up with. So if you notice, the difference is at the bottom it says levels. So this happy variable has 2 levels, happy face and no happy face. Okay, so that's it. And in terms of the research is, so this data comes from Rind and Bordia, 1996, and in their investigation, basically they investigated whether drawing a happy face on customers' checks increased the amount of tips received by waitress at an upscale restaurant on a university campus. Okay, so in their design, during a lunch hour, a waitress drew a happy face, smiling face on the checks of a random half of our customers, and the remaining half received a check with no drawing. So this is a perfect case to compare whether there's like differences in terms of how much tips each customer groups gave, and then yeah, this is a perfect case to run an independent t-test. And yeah, independent t-test basically compares 2 sample means. So yeah, and in this design, the research question basically, do customers that receive a happy face on their check differ in their level of tipping as compared to customers that received no drawing? The first thing always is, let's check the descriptive in this data set. And to do that, basically you use the DEC function again. So DEC, and then if you type my data, it's going to give you the descriptive for both variables. If you want to look at the individual variables, you basically need to call the individual variables. So let's run this one. Look at the data set first. Descriptive for this data set. Okay. We don't need the plot. I'm going to minimize that. So in this data set, again, we have two variables, 45 observations and 45 complete cases, no missing data. And the first variable is numeric tips. And with the numeric variable, you can get the mean and standard deviation. So mean is 30.77, and the standard deviation is 9.3. And this also provides lowest and highest numbers. This is also a nice way to check whether there's any issues in your data set. For example, if you see a negative tip, like -10, then you may need to check back your data and the data quality. And the second variable is happy. And in this variable, we have two levels, happy phase and no happy phase. And it looks like in the happy phase, we have 22 customers who received their happy phase and 23 customers who didn't receive a happy phase. And it's about 48.9% happy phase and 51.1%, 1% not happy phase. Okay. So, but if you wanted to look at an individual variable from this data set, instead of like looking both at the same time, what you need to do is like, again, DEC, call my data, and you need to call one of the variables. And let's look at happy. And if I run that one, I basically get the same results. So it's the same results. Since we only have one variable, the variables are not numbered in this one. And so, but what happens if you want to check the mean tips amount for both happy phase and no happy phase? We can still use the DEC function, but we need to make some changes. So the first thing is we want to look at tips by happy phase levels, happy levels. So basically the thing you need to do is you need to type the first variable in tips. And the tilde sign is kind of means by. So tips by happy. So if this was the gender, you might do tips tilde gender. If you have a race variable, you can do tips tilde race, or like any categorical variable, you can do it this way. And yep. And then your data set is my data. So let's run this one and see what happens. But before that, I'm gonna clear this one again. This little broom at top will clear the console, and I will run it after. Okay. So yeah, we get the descriptive statistics, and we get the descriptive statistics, and we get like some plots. So basically, for people in the happy phase group, the mean tip amount is 31.93. In the no happy phase, the mean is 29.67 cents. And you'll get the standard deviation, and like for both groups, and you get the N, you get the percentages. So, and then you also get a nice plot at the bottom. Okay, so we know a little bit more about our data set, and it looks like people in the happy phase groups tips about like $2 more than people in the no happy phase. So the next question is what, for us to test whether this difference is statistically significant. And to do that, and again in a t-test, we can have like 3 different hypotheses and non-directional one, and we are basically saying that there's going to be a difference in the mean tipping amount for people who received a check with happy phase and no happy phase. So we're basically saying that there's going to be a difference. And in the second one, we are saying that one is going to be greater than the other one. And in the last one, we're saying that one is going to be less than the other one. So I'm just going to run the non-directional for this exercise. But to explain that one, so again, the function is t-test, and the outcome is tips. And again, this tilde is like by, tips by happy. So we are looking at no happy face and happy face, and we're comparing the means for that. That's basically what it means. And you need to tell R what your data file is, and you need to tell R what your alternative hypothesis is, and you want to make sure that you are testing against 0. Basically, you're saying that the mean for those two groups are going to be equal. Equal means like 1 minus the other one is going to be basically 0. I mean, you can change this mu, but that's kind of more advanced topic, so I'm not going to go into that one. And the next argument is paired. Paired is basically telling us whether we collected the same data from two individuals or separate, same individual or separate individuals. So since this data comes from different customers, then we are saying that paired equal false. So our data set is not paired. And we're going to use the variance equals assumption, and we're going to say that true. If we assume that variance is not equal, then we are going to use false. But again, these are more advanced topics, so I'm not going to go into that here. So I'm just going to run this one. And let's see. But before that, I want to minimize this and clear up my console so that I can only see the results for this part. Okay. So again, R is telling us that it ran a two-sample t-test and tips by happy. That's the data or the variables that we are using. The t statistics is 0.8 and the degrees of freedom is 43. And the p-value is like 0.42. So since the p-value is greater than 0.05, we fail to reject the null hypothesis. So basically what we're saying is there's no difference in terms of tip amounts for customers who received a happy face drawing on their checks or the customers who didn't receive a happy face on their checks. So it looks like drawing a happy face doesn't have any statistically significant differences in terms of the amount of tips the servers receive. Okay, and you can also get the sample mean estimates with this analysis, but this is exactly matches what we saw by running this descriptive. So let's double check that, and I'm going to minimize this. So yeah, happy face group 31.93. So this is rounded and this is not. So okay, that's all for running an independent sample t-test. So again, in this exercise, we compared the means for two groups: customers who received a happy face on their checks and customers who didn't receive a happy face on their checks. Okay, that's all for independent sample t-test.